This lesson will give you some practice in Chapter 5, Section 9, percent change. And let's define percent change. Percent changes can happen in two ways. If something increases when compared to an original amount, it's a percent of increase. So a percent increase is a change that describes an increase or a rise, getting larger from the original amount. So it's not what the original amount is, or it's not what the new amount is, it's how much it changed. So, and the percent decrease is a change that describes a decrease from the original amount. Here's the definition of how you can find percent change. Compare the amount that something changed to the original amount, and that'll equal the percent of change over 100. And this should look somewhat familiar, because it's just a modified version of part to whole equals percent. So how much something changed would be a part of something, and the whole thing would be representing the original amount. So if, for instance, if something, well, I'm going to do a problem in a second where we'll imagine that you were originally 60 inches tall, and then a year later you were 66 inches tall. So your original amount was 60, and the amount of change would have been 66 minus 60, or 6 inches. And that would, so we'd have a proportion that 6 over 60 equals n over 100, and we solve for n, we'll figure out what the percent change was. And it would be an increase because it went from 60 to 66, so it got larger. When we talk about some things about business, a markup is considered to be the same as a percent increase. A markup is the amount that someone they buy something for a certain amount with the intention to sell it, and of course they want to make a profit, so they mark up the price that they're selling it for compared to what they bought it for. So if you buy something for $4 and then you try to sell it for $5, you've marked it up $1. A sales tax is also an increase because you're going to have to pay more. If there's a 10% sales tax, you pay 10% more than what the actual price on the item is shown as. And a discount is a decrease because the seller is going to take something, a percent off of their asking price, their original asking price. So we do an easy example of this. If something is selling for $100, and it's offered at a 20% discount, they'll take $20 off. So the amount of discount would be $20, and in this case it would also equal the percent of discount, which would be 20%. So let's look at a couple examples of how this can work. You know what, I'm going to wish I had left that up there. So I'm going to put it right back up. The amount of change compared to the original amount. And this part's going to involve doing a subtraction problem. Equals the percent of change over 100. Okay, so let's take the example where you measure your height and you're 60 inches tall, and a year later you measure your height and you are not still 60, you're 66 inches tall. So the original amount here was what you started with, 60 inches. And the amount of change, again, involves a subtraction problem. You have to do 66 minus 60. This is the part that gets some people confused. They automatically put 60 and 66 in these two slots. But you have to find out the amount that something changed, which suggests subtraction. So it would be 66 minus 60, which is an easy problem. That's 6. We want to find the percent change. We don't know it, but we know it's over 100. So when we cross multiply, something we've been doing a lot of this chapter, we would get 60 times n equals 6 times 100. Divide both sides by 60. You take a 0 off there. Take a 6 off here. That cancels, and n would be 10, which means 10%. So it's a 10% change, and that would be a 10% increase because it describes an increase from the original amount. If I would have known that there was a 10% change in someone's height, I could put a 10 here. And if I wanted to know if their original height was 60 inches, and I wanted to find the amount that it changed, I could solve this proportion. N over 60 equals 10 over 100. Or if I knew it was a 10% change, 10% change, 10 over 100, and the amount of change was 6, but I didn't know what the original amount was, I could solve this proportion, and of course n would be 60. So if I know any of these two of these three numbers, two of these three things, I can figure out the one that's missing just by using proportions and just filling in the slots. When we did the part to whole equals percent, we were suggesting just draw the sort of the framework for doing the part to whole equals the percent and just fill in the two of the three things that you know. You can use the same strategy with percent change. Fill in the framework just like this. This will be how much something changed by, this is what the original is, and this is the percent change. If you know two of the three things, quantities, then you can figure out the missing one. If you only know one of these three things, then you can't do anything with it. And you can do a lot of rather elaborate math. Again, I wanted to make that disappear yet. And this is one way that you can do some problem solving with the kind of problems that you're going to be presented with in practice today, but you should also realize that you might find ways that you like that are intuitive that you could do more quickly, and I may mention those just so you're aware that if you thought of that, yeah, you can do that. It's okay. This is a rather elaborate question. It's from page 123, number 5 on page 123. And it has many steps. It talks about a seller who buys something to sell. So he's actually a buyer and a seller, but he buys something for $25, and then he marks it up at 110%, so he more than doubles the cost. So it's going to be 10% more than 25 plus 25. Well, I didn't say that quite right. We'll see. But that gives you an estimate that it's going to be about $50+. Then, when the person buys this product, whatever it is, from him, there's a 6.4% sales tax. And the question would be, how much does this business person sells something to a customer, how much does the customer pay after they paid the added on 110% and they added on 6.4% of the sales tax? And the sales tax is actually calculated on what the seller is asking after the markup. So we have to figure out what's the asking price when you add on what basically is the profit for the seller. Then that amount's going to be taxed. And that tax would typically go to the local government, state government, city government, federal government. It's a tax that's not going to go in the seller's pocket, but it's going to be used to provide goods or services for citizens of that area. So what we want to do first is say the original amount would be 25. The markup percent change is 110. So when we solve for n, we're going to be figuring out how much the seller marked it up. And I think I'll save a little time here and just say, when you go through this whole process, well, I probably better do it. 100 times n would equal, this is 100 times n, 110 times 25. Divide both sides by 100. I'll just save a little time there and knock that off. I'll do 5 into 10 goes twice. 5 into 25 goes 5 times. So n would equal 11 times 5 divided by 2. 11 times 5 is 55. And half of 55 is 27.50. So the markup amount is $27.50. That gets added to the $25, which means if you see the price tag on the site, it would be 25 plus 27.50, or $52.50. So the price is set at $52.50, but now there's going to be a 6.4% increase by adding on that sales tax. So now our original amount becomes $52.50, and the tax rate is 6.4. So the percent change is 6.4. We don't want to forget this 52.50 because we're going to have to add a small amount to that. 6.4% of well, 6% of 50 would be $3. You can get that quickly by doing 6 times 5. And just realizing it's not going to be $30 if it's 6% of $50. So we're going to add about $3 to this to get the final price. So we would do 100 times n equals 6.4 times 5250. Divide both sides by 100. Now this gets a little tricky. You can't just cancel that. You can't just knock off that 0 and that 0 because you can take that 0 right off there. It doesn't mean anything anyway. Because it's to the right of the decimal. 52 and 50 hundredths is the same as 52 and 5 tenths. So be careful with that. In fact, I probably want to be so careful here. I just advise you to do 6.4 times 52.50. And if you do that, you're going to get 330. I'm just going to say what you get: 336.00. And then that would be divided by 100. Well, again, you can't just knock these two zeros off. You can erase these two zeros. It's like 336 divided by 100. And if you do that, dividing any number by 100, all you need to do is move the decimal 2 places to the left. So this would equal 3.36, which is $3.36, which is very close to the estimate that we had, that 6% of 50 is $3. It's a little more than 6%. It's a little more than 50, so $3.36 is very reasonable. So the price tag is $52.50. The local government wants to add on $3.36, and so the buyer is going to have to pay an additional $3.36. So their cost would be $52.50 plus $3.36. So what someone buys originally for $25 ends up costing the customer $55.86. And that's about as complicated as it gets, but it's all based on this idea that you can use proportions to figure out percent increase and decrease. Now, what you might have thought of, I mentioned earlier in the video that you might have thought, well, isn't there another way that would perhaps be simpler? And you might think it is. You could do 110% of 25. 110% of 25. Of means times, this is using the equation method. 110% is 1.1. And if you do 1.1 times 25, you get 2750, which would be the amount of the markup. So you'd have to add that on to the $25. Likewise, you could do, you know that total is 5250. You could find 6.4% of 5250. And convert this to a multiplication problem, 0.064. Remember, you have to move the decimal 2 places to the left and drop the percent sign, times 5250, and you would get 3.36, which is $3.36. So, you know, it's sort of, you should be able to use both proportions. The amount of change with the original amount equals percent change over 100. Or you should be able, can be able to use equations. But the focus on, if you study page 122, it's exclusively devoted to how you would solve it using this approach, which is using proportions. But you can use what we had learned earlier about how you can translate a word phrase into a mathematical statement. Both ways of solving this problem would work for you. Thanks.